Hello, this is Dr. Bruno Gobato, and I'm going to show how to plan a reverse total shoulder arthroplasty using the Windows 10 software called 3D Builder. First, let's open our CT scans DICOM files in Invesalhos. Other alternatives are the 3D Slicer, Osiris, and Horus, all free software. Select the threshold for bone and just click on Create 3D Surface. With the 3D reconstruction of the shoulder, let's export it into a STL file for further working. Now we are going to open a software called Mesh Mixer and import this 3D file in order to separate the scapula from the humerus. We just select the humerus and click in Delete to have only the scapula bone. Next, we are going to correct some errors. Just select the file and Analysis and Inspector. 3D files generally have many errors. This step is very important to avoid problems in 3D printing and in planning. And to have a smoother 3D file, we just select Edit and Smooth. We will have a better surface to work on it. Let's export this file we have just created into a scapula STL file to open in 3D Builder. Now just import our scapula file into the 3D Builder. It's a native Windows 10 software, and import the glenosphere file to plan our surgery. If you don't have your implant in a 3D file, you have to draw it yourself. That's what we're going to show. In this example, we have a 28mm base plate and a 36mm glenosphere. This freedom is important because now we are available to choose any implant, even the old ones. Let's create the base plate. Let's insert a cylinder, choose the 28 diameter and create another cylinder, which is the central post for the base plate, and align them to have the base plate done. The yellow cylinder we just created is the central pin for the glenoid implant. In the surgery, placing this pin is the first and the most important step. Let's create our glenosphere. Let's insert a sphere, 36 diameter sphere, and let's edit to split in half to have an actual glenosphere. Just select Edit and Split. After aligning everything, we now have our glenoid implant. The glenosphere, the base plate, the central pin guide, and the central post. Let's export it to a reverse total shoulder 36 diameter glenosphere. Now it's time to actually plan our surgery. Let's open a new file and import our scapula 3D file. Select the scapula and rotate it to have the best view for planning. You can use the Object menu to have measurements for your scapula. You can measure the glenoid, you can measure the scapula, you can measure it in any plane you want. Here we have a 32 by 40 millimeter glenoid. The next step is to analyze and visualize the retroversion of this glenoid. I suggest splitting the glenoid in half, but maintaining the superior and the inferior part. Now let's import our implant, the 36 millimeter glenoid. Just insert it into our file. Now we have the glenoid, the scapula, and the implant. Just rotate it and align it to the best fitting way. We must check our anterior-posterior position in order to address the glenoid correct version. Adjust the inferior position and the inferior tilt, whatever you think is the best for you. The next step is to know how much we are going to rim to have the glenoid version corrected. You can just measure how much is needed for that step. we suggest double checking everything, and now we can delete our implants and have just the central pin guide, which is the yellow cylinder. If you want to stop here, you can just 3D print this scapula file with the central pin guide and use as reference during your procedure. But we are not done yet. We are going to show how to create a patient-specific guide in the 3D Builder. Insert a cube object and adjust its dimensions to fit a glenoid. Relocate it in the best fitting position for a patient-specific guide using bone reference. Once you are okay with the bone reference, just select the guide, the green box, and select the central pin guide, which is the yellow cylinder, and select subtract. Now we have a hole in the guide, which corresponds to the central pin, and subtract again the scapula to have the guide matching the surface of the glenoid. And now we have a patient-specific guide created by ourselves in the Windows 10 3D Builder. We can export it in any 3D printer and use for our surgery or for practicing. And here is the 3D printed guide. This is the 3D printed scapula. We have printed in ABS for this purpose. And here we can see the guide printed in PLA and how it fits to the glenoid. The central hole has the direction we choose for the central pin of our reverse total shoulder arthroplasty. Thank you very much. My name is Bruno Gobato. My email is bgobato@gmail.com.